Cool. Thanks everyone for joining the Scalability demo. We're a bit with a small crowd today, but Jakob, you have an item on the agenda.
Yes, it's unfinished, but I think it's there's already lots of food for thought and things I want to share. Let me share my browser so that it's easier to know what we're talking about. I'm working on an issue where we're trying to add latency metrics to all the Redis servers because we're focused on Redis observability right now. And so I really only care about this top row of the dashboard. We have 3 distinct Redis services, and they each have their own dashboard, but they look almost the same. And up until last week, there wasn't even an error ratios panel here. And for context, what we expect to see is 4 panels: latency or apdex, error ratio, request per second, and saturation. Error ratios are super boring. There are no errors. This was already discussed last week, which is awesome. But I still think it's useful to have the panel, because if you know how Redis works or how we use Redis, then maybe it's obvious that there are no errors. But if you don't know that, it's not obvious. And this makes it obvious and it makes it uniform. So I still think there's value in knowing this. But yeah, so now I'm working on towards the 4th panel, and that is latency. And that one is less rosy than the errors, because it turns out that latency isn't all that great, or it's not what I expected it to be. And now we need to digress into another specific technical aspect here, which is that we need to measure these things on the client side. Redis is meant to be very fast, and if it would log everything it's doing, it would slow down just by having to do all that logging. So you get only very limited information out of a running Redis server about what's going on. And it's great that it's fast, but that limited information is a challenge. So in this particular case, we decided to measure on the client side. And that is a fairly sane approach, because GitLab is mostly a monolithic code base, and almost all the Redis use is in the monolithic part of the code base. So if we measure Redis there, then we probably see 99% of what we do with Redis anyway. So we might as well say that is how the Redis server is doing. So that's a practical solution, but yeah, some things look slightly different. One thing that I found surprising is that in my mind, Redis is supposed to be fast. And it is if you think about what the Redis server has to do. But if you think of the bigger picture of what the experience from the side of a Redis client, it turns out that Redis is slower than I thought. So I was thinking, well, a Redis request should take like 1 millisecond or 5 milliseconds would be really slow for Redis. But it turns out that, so that was my expectation. So what I did is that we created a histogram in the Rails code base where we have, actually this code is new, this wasn't there yet. The slowest type of request we could observe was 100 milliseconds. These are seconds. So anything slower than 100 milliseconds I thought is so terrible that we don't even want to think about it. But it turns out that if you look at 99 percentile latency, then it's just constantly above 10 milliseconds. And another thing I had to learn here is that, which makes sense in retrospect, is that a Prometheus histogram can only come back with the value of the largest bucket. Anything that is, any observations that are higher than the largest bucket value get reported back as that largest bucket value. So all this tells us is that there's a bunch of calls that took more than 10 milliseconds. And yeah, the 99th percentile is always above that. And yeah, except for this one thing, which is the shared state Redis. So sometimes this is fast, and you get 0.06. So that is 6-ish milliseconds. That's not really, yeah, I won't bore you with the math, but it's less than 10 milliseconds. It's closer to 5 milliseconds, which is the next bucket. But this is slower than I expected. And another way of looking at this is to look at the percentage of requests that is within a certain that is not too slow. This is roughly the AppDex idea, although AppDex is slightly more complicated than this. But what I plotted here is percentage of requests that takes less than 10 milliseconds. And that is, well, here on this line, this is the blue line, that is the shared state Redis again, that is 99% here, but it's dipping to values like 97%. And then this cache instance, it's more like 98.6. And then here it dips to, again, 97.4. And this is the Sidekick Redis. And this dips to 85%, meaning that 15% of requests at this point took longer than 10 milliseconds from the client side. So I've been having a discussion with Andrew about this, and this is not usable for our latency monitoring. And we just need to own up to the reality that from the client side, these things are slow, and we need to have the buckets that allow us to reflect that.
Yeah, I mean, the thing to keep in mind as well is that that's obviously including network round trip and the data transfer, and we do some rather abusive things with our Redis with very big objects that we shouldn't really be storing in Redis. Traces comes to mind here.
Yeah, exactly. This is one of the things I learned as we worked on Redis, is that even though people always say Redis is single-threaded, but it's really the part of Redis that looks at a request and writes the response somewhere in memory that is single-threaded, but then it tells Linux to send that response back to the client, and that then gets done by the kernel in a different kernel thread. And so it can take much longer for the data transfer also on the server side.
And actually in Redis 6, they've offloaded a lot more of the non-critical stuff outside of the thread. And so, for example, if you go look at the Sidekick documentation, they say if you move to Redis 6 and you switch on this feature flag, which I can't remember what it's called offhand, they say you'll get much higher throughput. Because of that as well. So there's more to come.
That's great. But I think it's sort of a blessing in disguise that we have to monitor on the client side, because it's ultimately more relevant.
Exactly.
And what we're discovering here is exactly how bad things are on the client side. And what I would really wished for today is that I could show you this dashboard. There'd be a fourth panel here, and I could say, look, this is how we're doing. And I can't, because I had to go back and look at the buckets, which dovetails with another interesting topic that I'm just going to mention for a moment. This came up, Sean brought this up a while ago, and then Andrew also brought it up, and it's sort of going around that we have too many latency buckets on our histograms. And this is flooding our Prometheus servers. And I took this as an exercise to say, let's have very few buckets. In the first merge requests, again, there are 4 buckets here, and this is a very small number by GitLab standards. This has to do with the difficulty of defining buckets, because ideally the buckets should be sort of focused on the range of latencies you care about. But if you don't know what those are yet, how do you start? And the process we've been using all along is to say, well, let's just take a lot of buckets with an exponential range and then see what works. And then we never go back and kick out the buckets we don't need. And so this one I thought, okay, let's try something different. Let's focus on what I think it needs to be. And then I immediately run into the pain of, oh, now the alerts don't work and I need to go back and create a second merge request to change the bucket definitions in Rails. So for me, it's an interesting learning experience. I'm not really sure how to share this learning with others or how this informs what we want to be doing here.
Here's an interesting, slight detour. But if you cast your mind back to about February 2017, when we were putting observability into GitLab, and I remember we were having a lot of discussions around this stuff at the time, and we decided on some buckets, but then we also made it configurable in the GitLab config, which is, I think, the only place in the GitLab application where the buckets are defined in configuration. And I wonder whether this would be something that would be generally a better way to go, because like you can see the pain that this, you know, it's
also this is
finicky.
specific to our infrastructure, potentially.
Exactly.
So
Yeah.
I think you're right here.
Yeah. Also, because we've kind of decided we're not going to use latency histograms in this way because they don't work for us, because we have other cardinality problems that are coming into play, like the number of servers. We saying we want 3 buckets, but a lot of clients, they're going to say, what kind of buckets are these? Like we're not going to get any resolution. Our histogram estimations are going to be terrible. And so maybe it makes sense to kind of extend out what we did on GitLab to a broader audience.
I think that sounds very reasonable, because this hard coding is painful from the developer point of view, and I'm pretending that GitLab.com is the only installation that cares about these buckets, and that's why I'm hard coding them, and nobody's challenging that. But in all honesty, that's not true, like you just said. So
also, if anyone else is using latent aptX scoring, every time we change these buckets, we'll probably break their aptX score, which won't please them very much.
No,
but
that's
I
another
don't think we should ever, I mean, we should never kind of say that the metrics are stable, because I mean, we'd really kind of hamstring ourselves, but it is a thing to think about.
But this is a mistake waiting to happen. And just to spell it out for those of us who are not super familiar with this, the aptX panels we have in the metrics catalog are standardized. This is the system Andrew's been building, and they all use the same formula, the same Prometheus query, and these do counts on exact bucket values. So if you move the bucket boundaries, for computing histograms, moving bucket boundaries is irrelevant, because the histogram is just takes whatever buckets exist and compute a value out of that. But the way we do aptX, we care about actual bucket values. And with this slow process where we change a bucket, merge it, wait for it to be deployed, it can be that we find out the next day we broke our alerting, and then we need to go back and change it again. And if this was in configuration, then we would be able to fix a mistake like that much quicker.
Yeah. There's another sort of related issue that I ran into this week, which is that I realized that we can treat the Google load balancers that we have in front of a lot of our services in the same way that we treat HAPoxy, as a kind of external ingress, but we kind of count it as part of another service. So we do that for registry and stuff. And one of the nice things about the Google load balancer is that actually, unlike HAPoxy, it's also got latency histograms of how long requests are taking. And so we don't have that, for example, for Grafana. Ironically, Grafana doesn't give us latency histograms itself. And so sometimes when things are running slowly, it's very difficult to know what's going on. But we can get it from the Google load balancer in front. But the problem is that they use a purely logarithmic calculation on the bucket sizes. And so the bucket sizes have got these really ridiculous names, like 10.000423895, like 10-digit long latency values. And so I was trying to figure out, is there a way that we can do it without those exact values? And the best I could come up with was a regular expression, which is probably worse than nothing. So it's kind of I don't really know what the answer is, but.
You mean that if we want to calculate aptX from Google's data, we need to put these ridiculous numbers into our formulas?
Yeah, we have to exactly.
And we have to pray that they never change them.
Exactly, and we have to pray that the way that JSON represents that float to the 10th digit is the same. I mean, we could probably just.
No, it's not a float; it's a string anyway. So that I'm not
no,
worried
but
about
it's
that.
in JSON, the satisfied threshold is a float, but we can change that.
We might want to change that, considering it is ultimately a string and it has to match a string.
Yeah, there's some rules in Prometheus around
Right.
the representation of that string, but lots of things break those rules and don't actually adhere to them correctly, interestingly enough. But yeah, so it's very fragile is the kind of the point.
So we keep learning all these interesting things about monitoring.
So there's one more little extension to that, which is that one of the interesting things that we could potentially do, but we'd have to change the Prometheus client a tiny bit that we use in Rails. Because one of the things I'd really like to do is put those thresholds into the application and not into the, in a separate place. So we only have a single source of truth, right? And one of the things we could do is if we had the thresholds configured, we could mark 2 of them as the aptX thresholds, right? So, I mean, you can say this one's satisfied and this one is tolerated, but really, it's the lower one is satisfied and the higher one's tolerated. But effectively, yeah.
No, I want to come back to aptX, but finish your thought first.
Okay, so because then what you can do is that you can expose that on the latency histogram, but only on the special thresholds, and then you can basically sum those and divide them by the infinity bucket, and you don't have to know what the values are. You just say, sum the thresholds and divide that, and then you get the aptX, and then it's all managed in one place.
Yeah, that makes more sense, because now even if we push the bucket definition into config, then we still have chef somewhere, and then we have runbook somewhere else, and we need to make sure we use the same numbers. So yeah, that would be smarter. What I wanted to ask about aptX is, I don't know if you noticed, but I ran this query where I just said all the requests that are less than 5 milliseconds, and that is not the aptX formula we use in the runbooks. And so I've been also looking at I've also been looking at the second Google SRE book, the SRE workbook, where they talk about alerting and these sort of things and how to define SLOs. And it seems like aptX is, like, intuitively, I'd say the simplest thing to say is number of requests that is below a threshold, but aptX is slightly more complicated than that.
Because of the tolerated.
But it's actually, the way I understand it is that, what does it actually mean? Because it's the average of the satisfied,
so it comes from the
and tolerated.
It's the average of the, sorry, the way, this is how I think of it. If I was to explain it, it's an error budget. It's a type of error budget based on latencies rather than like a traditional, like your request is errored. If a request comes in at less than or equal to satisfied, then it's 100%, no errors, so 1 out of 1. If it comes in less than or equal to tolerated, you give it 50%, and that's the weird thing. But then other than that, you treat it as a latency error. So, but a lot of our aptX thresholds don't have the tolerated. So they've only got a satisfied, and there's various technical reasons why it's like that. And for those requests, it's effectively a straight error budget. And, and it's much easier to
exactly. And my question is, I'm sure, I think the original aptX was even more complicated because it would exclude error requests, but we have thanks for that explanation. Why do we need the more complicated version instead of just saying satisfied or not?
So really what it is just kind of sticking to the standard, but like often and kind of probably tending more so, I tend to leave out the tolerated, because exactly the same thing that you see here. It's much easier to sort of cognitively process. It's like, this is the number of, it's a pure error budget in the same way that errors are. But what you'll find is for a lot of our services at the moment, we kind of need that half score in order for them not to look really bad. So if we took away the tolerated, we would probably go down quite a lot, and all the multi-burn stuff stops working below 99%.
But this is very interesting, but you can, because we had the same problem in the discussion about how to set these Redis buckets, but the status quo is that things are as fast as however they are. And
so we're kind of bumping them up.
And we're trying to come up with SLOs, and I think the way I look at it now is that we probably want to have SLOs that capture what is going on now and say, this is reasonable, even if it's not. And
But
then
that's what
at
we've
least,
been doing,
at least then we know if something slows down and becomes even worse than it is now, we know about it. And then a future step is that we tighten those SLOs and say, actually, we want Redis to be twice as fast, and we're going to start measuring if we're there. And once we get there, we lower the alerting threshold.
That's exactly it. And all of the budget, all of the thresholds that we've got are based on what was available, right? It wasn't like what you're doing now is you're manipulating the buckets, but almost everything else is like, well, this is the best bucket we've got, so we're going to use that. And, you know, like over time, we will start improving that. Sorry, you had something to say, Maren?
Yeah, I wanted to actually ask because in my head, I thought that we, like the reason why we wouldn't want to use tolerated in the abstract calculation is because it gives us, like you said, it's cognitively more, like it's easier to grasp it, but I also doesn't.
No, it's harder to grasp, is what I'm saying.
What?
Not using it is easier.
Having two thresholds is harder than one, is what I think it sounds like we're on the same path.
We are on the same page. We are on the same page.
Okay, just checking.
But what I was trying to understand is, doesn't that also mean that you're forcing yourself towards a higher standard because you don't have that in between state, right? So why is that bad?
Because it's not bad, and that's something we would like to go to. So say we have at the moment, we have a 1 second and a 5 second for workhorse, right? I'm just going to use like hypotheticals. So the choices are, okay, we're going to drop the 5 second. We're just going to use the 1 second. Then you might find and this is all hypothetical, I don't have the numbers in front of me, but you might find that workhorse runs at like 98%. And as soon as you go into those sort of territories.
Yeah, no, I get it. So you just said it earlier.
Yeah.
In some places, I'm going in and I'm redefining the buckets so that we have good buckets. In some cases, we have not gone back to redefine the buckets, and instead we use tolerated to create an in-between bucket that doesn't exist.
Exactly. And you know, the thing is, like, if you go back 6 months when I started writing all of this stuff, I was kind of like, if I go through and change every exporter, every application, you know, every histogram, this is going to be like years of work. So let's like use what we've got and then iterate on that. But I don't think that those are the, you know, some of the buckets are terrible. Like I think for API, the tolerated, it's like 30 seconds or something. But purely that gives us the numbers, and we should do a process of reviewing them. There's one other thing that I want to add, because I think it's an important thing in this discussion, and it actually ties into some of the conversation in the group conversation last night. And that is that at the moment, we've managed to separate what Sid was calling the SLOs and the SLAs, which I call the monitoring thresholds and the contractual thresholds. But the thing is there's one part where they're still the same, and that is they still use the same thresholds for the aptX scores. And if we want to do this properly, we've got to break those apart as well, because if we go and tighten all these thresholds up, it's going to screw up the contractual ones without any change in the actual latency of the. So I've got it's easy because everything's in JSON. We can just kind of, and all in the metrics catalog now, we can just generate something to do that, but it's a task that has to be done.
Yeah, and it sort of circles back to so thanks, you've sold me on why we have the funny aptX. It's because we don't want to go back and change the metrics, the buckets all the time, which is exactly the pain I'm feeling today and yesterday. So that makes a lot of sense. But even, especially when you're talking about SLOs and SLAs and maintaining a more complex set of thresholds that with higher business consequences if we mess them up, it seems like it's even more important to have a system that is sane to work with, and something that's maybe a bit more friendly to work with than what we have now. Because right now we have buckets that are hard-coded or that don't make sense, and we have runbooks that need to match things that exist in the buckets, and we use AppText to create in-between thresholds.
So there's several approaches that we can. So the first thing is, I think we've got to split this. It's actually not as difficult as it sounds, because we only need this now because the SLA metrics, we're only recording on the key services, and that's Git, Web, API, Registry, and CI. I think are the key services, right?
CI is not.
No, CI is not. Sorry, I beg your pardon. Yeah. So, but what I'm saying is it's actually a smaller subset of the services. So, like, it doesn't really matter as much for those ones. But then what we could start, we could go with those and define separate thresholds for those. The other way that you could do it, which is a little bit more kind of, I think it might be too confusing for people, but is almost on a per request in the application. We have a counter. So effectively the counter is, did this request complete within the within a reasonable amount of time? And then effectively you divide that by the total number of requests and you get the same thing, but then you can vary it per endpoint. And again, you're pushing it back into the application and you're not relying on the histogram infrastructure in order to build up that score. And effectively it's just like it's an error counter. Do you follow?
Yeah, you're trimming down the whole histogram mechanism to only the part we need, and you're pushing it into the application.
Which is the error rate, yeah.
Yeah, the error rate.
Latency error.
Yeah.
If you want.
Yeah. No, I was just looking at the Google book, and they make the point of saying we're going to talk about error rates when we're going to say error rates when we talk about latency, because it's sort of the same thing. Yeah, it's the thing we don't want. I suppose that might have the advantage that if we want to head towards a future where we can break things down by feature category, you might be able to see if feature
you don't have all the buckets.
No, but like you can. The current breakdown of Web API Git is quite coarse, and if we want to have a situation where we can say, I don't want to pick on any feature category, but some feature, and we want to be able to say, hey, compared to your goals, your feature is often quite slow in production, and maybe you need to spend time looking into this. The only way to do that is if we can break things down per feature. Then we need to be inside the application. And
no, I don't think we do. I think it's a great thing, but I think it's orthogonal, because once Bob's work is finished with adding the feature category onto the controllers,
right,
or the action
ones,
you don't need to have any other application changes once, and you need that in both cases. But so it would be a different way of doing it. It might simplify some things, but it's not necessary, if you get what I'm saying, because you can.
I think it, like from an optimization point of view, it makes some sense, because you're only counting the things that you need to count, and it will probably scale better in the end. But it's highly specialized to what we're doing, and it might be more, like you say, it might be more confusing to people if it's not histograms and it's the one part about histograms we care about counter.
Yeah, I mean, you could just say that, we make it like GitLab, where you can turn off the histograms, or you can put them on and use your own buckets. But effectively, for the service level metrics, we're just counting an error rate. I mean, the way that I was imagining it was it would go into in particular for LabKit, for the Go services, we could just build it in as a middleware in there, but we don't really have that for Ruby yet. Yeah,
it's interesting. My main takeaway is that the current system is too fragile, and we need to do something. And this will be one way of dealing with it. And your other idea of configuring buckets and saying these are this is the one that means satisfied.
These are
and then exporting the data as histogram is sort of the same.
The only risk I have with that is, Prometheus is quite, and I don't know if this is a real risk or not, but we just have to test it. Prometheus is quite delicate about label matching. And I don't know if you had like a histogram made out of, say, 10 labels, and 8 of those labels matched on everything except LE, and then 2 of them, say they had the is aptX threshold value. Then,
I don't really know if we can do that. Is the problem, because you need to.
We own the Prometheus client, so we can.
Yeah, I'm not sure if that is a great idea. So
that's what I'm saying, is we'd have to test
for the benefit of the people who don't have this in their heads, let me spell out what I think what we're talking about. Prometheus in its internal data model has histograms, which are things you just say with buckets, and you say I saw a number and put it in the right bucket. And these get exported as a series of individual counters. But that is sort of how the wire format works. And you define one bucket when you have a Prometheus client. You define a histogram. You say these are the histograms, these are the buckets, and that will create, I don't know, 10 different counters, and they will have the exact same label sets. And what Andrew is saying, that some of the observations will get a different label value on there. So we're changing the wire formats of the histograms produced by our special Prometheus client. And to be honest,
that's a bit scary. The other thing,
I find it very questionable. Like, you'd have to.
Totally. Like, I think it would be, but the other way of kind of putting it is there's no such thing as a histogram in Prometheus. There's only a histogram in the Prometheus client, and then everywhere else it's just a counter.
Yeah, sure.
And it's all just
But if we're going to expose our own funny counters, we might as well call them GitLab's funny counters instead of saying it's a Prometheus with the GitLab hack on top, and you get some extra values in there.
Yeah, what do you mean you don't support weird? Yeah, so I agree, and so maybe then going with the error, like effectively latency error counter is the other thing that's kind of interesting about that approach is that at the moment with aptX, I don't want to kind of jump too many steps ahead, but it's something to think about. At the moment with aptX, we always score it out of like good is 100% and bad is 0%. And then with error rates, good is 0% and bad is 100%. And if we just started treating like a latency error as a different type of error, I'd still keep them as 2 separate dimensions effectively on the dashboards, for example. But effectively, they're both good is 0 on both of them, right? And then if you have a bad
that's orthogonal. We can already do that.
Yeah,
we can do one minus on what we have now, and then you have to.
It should just be very confusing if you called that aptX and you had the tolerated and all of that in there.
We might want to move away from aptX or come up with different word that is where it's very clear what we mean.
Latency error.
Maybe latency SLO.
No, because SLO is sort of the next. But yeah, like a latency violation and yeah,
something along those lines. Yeah, I think the biggest issue, sounds to me like is having the biggest problem we have now is that the system only works because we use the same magic string in different repos, and it all comes together and we get the right alert.
But in fairness, right? The system that we've been using that with kind of predates the metrics catalog by like at least 1.5 years. So maybe 2 years we've been using aptXs for all of this stuff, and it doesn't break very often, if at all. And we do have alerts, to make sure that one of those series disappears, we get an alert on it. And those, the only one we get that for is the errors, but that's a different thing. So it doesn't, it's not as
maybe it's
fragile in design, but in practice it's not as bad. It's not that bad.
But it's hard to make changes to, and we were just discovering that we are taking the average of 2 types of latency error rates or latency non-error rates to compensate for not having the right buckets, because editing all these things is such a pain. So
Yeah.
yeah, the real problem is that fine tuning the system is has a lot of friction.
Yeah, and then using a separate counter, which you can kind of just plug the threshold in on that counter, might be a. The other thing that's interesting about it, right, is that you could then potentially, and this is just kind of like ideas are free. One of the things you could potentially do is you could say the threshold is 1 second, and then in the application, they could say, well, we know that these things are really expensive, like, I don't know, go off and fetch a source branch. So we'll just have a multiplier on that threshold for that particular request. And you can kind of, you can do stuff like that. Yeah, exactly. Because it's like a known slow thing that users are kind of going to forgive you for, or whatever.
I'm not sure. I mean, it's a nice idea, but I think complexity is something we need to look out for.
But
what I
if you're
like
thinking
about
of it as a violation rather than a fixed, it's like this is outside of the, but sorry, carry on.
Yeah, no, it could be a useful kind of complex flexibility to get a better signal. It's just that I think we need to be able to get a good enough signal without complexity and lots of fine tuning, or ideally. The other thought I had in favor of your latency violation counter idea is that clearly we're using histograms correctly is right. Sorry, using histograms correctly is hard. And if this allows us to move away from histograms, and we can make it clear about what these things are for. These things are for alerting, and this is our latency alerting infrastructure. And if you want to know how fast things are, that's not what this is for. Of course, one of the problems, of course, is then how do you find out how fast things are in the exploring way, where you don't know yet what things look like. But
I think, well, to some degree you should define that up front, and then but yeah, like I also think though that, like, if because I actually did think about this quite early on as well, like, should we do this thing? And I think that if we'd gone and kind of retrofitted all the systems with this, it's kind of like a step in that direction, like using the histograms, like the way it's described in the Prometheus documentation, like this is how you build it up. I think that was like a good first step, but like ultimately it's something we want to move away from, towards the violation. But not some, like, if we'd gone to that as the first step, it would have been like way too much, and everyone would have been like, what the hell is this thing?
This is one of the difficult parts. You need to bootstrap. You need to get
Exactly.
some sort of information about what the world looks like, and then say, okay, now we're going to build a system that squeaks if the world doesn't look like this. But how do you get that information in the first place?
Yeah.
I would like to interrupt you, if possible at all, and ask a question that is going to seem now like a very amateurish attempt of being in the conversation. But I'm sorry, you kind of went way too far, for me, at least. I want to ask a question about the Redis latency metrics that you're working on, and the fact that you said we're actually not measuring what Redis server is doing, we're measuring what Redis client is doing within the GitLab code base, right?
Yes.
What kind of information will we be able to extract when we see that things are going sideways? Like how are you going to use that information to dissolve whether code change created something or Redis network is failing or whatever?
Can I answer that?
Sure.
I don't know.
I don't have an answer immediately. It's a good question. So go ahead, Andrew.
So I mean, so we've been running this for Patroni for like maybe 9 months. So that if you go into the Patroni main dashboard, I can share my screen. Maybe that'll be easier. this is what we've been doing for this dashboard for quite a while, like at least 9 months. And this value over here actually comes from something called Rails SQL. So Rails SQL has got an apdex and an RPS, and it doesn't have an error. I don't think we don't do any sort of way of tracking errors. We probably should, but we don't at the moment. I think it wasn't immediately apparent. And there've definitely been times. I'm just trying to find like a good. I mean, I'm trying to remember. I think in November we had a bunch of problems with Patroni, and the signal was really useful to have. Obviously, the downside of it is, and I had to explain this on a few incident calls, like this thing is reading as Patroni, but it could equally be a bad application, you know, like a poor application change, right? And so there is a little bit of extra cognitive overhead for the person on call because it's saying Patroni, or let's just call it PG Bouncer because Patroni is a terrible name for this service. This service is running slowly, but actually because we're proxying the data from a different service, it could be something in between the two. It could actually be, you know, the PG Bouncer, it could be the application itself, it could be any number of things that's causing this. So there is a bit of cognitive overhead, but at the same time, it's also super useful because without it, in the same way, we wouldn't have that sort of latency information. And it is a very useful signal, even if it's like flawed in a way. I'm just trying to look here if there. Yeah.
To come back to Martin's question, I'm reminded of working on Gitly where we would have latency information and that doesn't tell you so much, and then I would be able to go into Elk and look at access logs, and then you can find out where it's coming from. And we're just not in the same situation with Redis because there is no access log. And so the question, like the latency number says something is bad. Now, how do we find out what is bad? I don't know. But where we're coming from is that we don't even get a good signal that something's bad or that something is slowing down.
And that's the primary purpose, right? Is to kind of monitoring and alerting.
Although we do have some access log type information because the Rails access log prints the total time spent in Redis calls. So if a particular thing is hogging Redis, then you can find it in Kibana based on that in the Rails logs. So yeah, there are these puzzle pieces. Go ahead.
The reason why I'm asking this is because if I think about the work that the CI/CD team is doing right now to enable traces to go through object storage or to go to object storage, what they're going to end up doing most likely is they're going to leverage Redis for this. Like they're going to buffer things and like post it there, and like I don't know how they're going to make that performant before they upload it to object storage in whole. Theoretically, that one can impact us significantly with this number. But how would we find out when they enable that or when they turn that on? Like how will we know that it was that and not five other things that enabled in production?
Rails application log, because of the work we've been doing in this epic, we have total number of Redis calls, we have time spent in Redis calls, and we have bytes sent to Redis, bytes returned from Redis per Rails request or per Psychic job. So if you have a Psychic job that is pumping a ton of data into Redis or out of Redis, that will show up in those logs. And you can aggregate that by controller and action. So you can see, hey, this controller or action is sending an insane amount of data to Redis, or it's spending a lot of time in Redis. So I think that would, if you know that those logs are there, you know how to use them, that can help you find the culprit.
Yeah.
Okay, so I have one ask for you, Jakob. We're at time. I have one ask for you. Now that you explained this so well, could you please add this to the epic? As in, what kind of benefits did we actually get from the work we've been doing? Because I've been digging a bit this week into the work that is being done, and I understand, like when I read the issue, I understand part by part what we are getting by this work. But for the life of me, I cannot put a picture together of how this will move the line for us once the epic is completed. So this is crucial information for me. Could you add that, please?
Yeah, I'll write something. It's Sean's epic, but he's out, and I'm happy to give my own version of what I think we did.
If nothing else, put it as a comment in the epic discussion section and get Sean to add it. But it can be more than that, because I think there is more than what you just said. There are like a lot of really useful things that we did. It's just that I can't explain them in like one go high level overview like this is what we're getting.
I feel your pain. But I think from my point of view, these are the most important ones, that we have the rich data and the Rails access logs so we can point fingers at requests. And we are getting some more signal of the Redis, if the Redis service is healthy or starting to slow down.
I don't think it's more important, right? It's like they're equally important, because you don't get the alerts unless you have this stuff, but then you can't dig further. There's a cheesy 3 columns of observability speech that I can give here, but they're all equally important, right?
The problem here is
and metric.
The problem, as I see it, is that we have an epic. We have 24 issues that happened in this epic that go in a bunch of different directions, and we learn something, we gather information, but which is the top line? What is the most important thing? And I have a take on that, but that is very personal. And it pains me to say it, but it might even be that the things I worked on look more important to me. So maybe I'm very biased and wrong, but I can still give my opinion. So I'm going to put my opinion on the epic and say, I think this is awesome that we can do these things now. And maybe someone else on the team will come in and say, well, actually, this other thing we worked on is also great. But
that would be excellent, because
But I'm going to pick the ones I like and that I think are valuable, and I'm going to write why I think they are valuable, and then we can take it from there.
So I don't know if you were in the group conversation last night, but Andrew, I'm going to
I wasn't.
Try to explain from the high level why I think this is kind of important to actually note down with every epic that we are doing, and Rachel's going to get a task to ensure that we keep doing this, is we know that we improved the platform over the past, let's say, a year. We know that there were a lot of efforts that pushed us over the line to now say that we can target that 99.95 reliably. All of these small things matter a lot, because if you go small things under air quotes, because if you think about us being in the incident calls, a year and a half ago, we would spend 9 hours in the incident call trying to discover what is happening and not finding it out. When you have information like this, you spend 5 minutes instead of 9 hours, right?
Yeah.
To get that information, which means that you can quickly find the culprit, which means that you can quickly resolve it, which reflects in the SLA in the end, right? So I want to be able to present that the scalability team is doing this type of work. And even if it's not our discussion, performance indicator, this is the performance that the team is putting out there.
Yeah, this is exactly how what I think should be the ultimate value that we're providing, or one of the ways we are providing it is, how long does it take to find out what the problem is in the incident, and how long, like in the case of psychic queues, if something is wrong with the psychic queues, how long does it take for them to go back to normal? I presume that this is one of the areas where you made a big difference with the psychic work. Yeah, so that makes total sense to me, and it aligns with how I imagine things work. The one thing I want to say is that as someone who is not in incidents, I can say I think this helps, but I don't feel like I know this helps. Will this type of things now get resolved faster? Have we communicated this well enough? Can we measure if it gets resolved faster? That I don't know.
Sure, that is all really hard to measure as well, because you can give the perfect tool to someone who doesn't know how to turn it on. Doesn't really matter then, right? But ultimately, even if we jump into calls, when I say we, I mean all of us in this call and watching this call, it means that we can actually achieve something
Yeah.
that we couldn't achieve before, right? So that's the difference, I think, we want to highlight.
Yeah.
Cool,
yeah,
thanks.
I'll sit down and write a comment with my personal take on what I think are the highlights of what we just gained.
Perfect. Thanks for sharing, Jakob. I think this was a good discussion, even though part of it I didn't even follow.
I was doing my best to interrupt the discussion sometimes and try and keep it to go out of control. But
no,
yeah,
it's fine. But I got my 2 questions that I actually wanted to ask, so that's good. Cool. Well, I think we can end the call here, and we'll chat all later. And I hope you have a good weekend, all.
thanks. Cheers.